Welcome and thank you for joining this webinar, The Architecture of Autonomy, Distributed Artificial Intelligence as a Native Capability of Future Wireless Networks, prepared by the Alpert Research Team. Wireless networks are entering an era where complexity, scale, and performance demands exceed what centralized control can manage. Distributed artificial intelligence enables networks to sense, learn, and act autonomously across devices, edges, and cores.
The future. How does this all get integrated into 6G and beyond?
And their vision is of the network becoming a programmable, AI-driven fabric. The idea is that the network stops being just a collection of pipes that we configure and starts becoming an intelligent substrate that can reconfigure itself. The ultimate goal they talk about is zero-touch provisioning. The network heals, optimizes, provisions new services, and defends itself against threats completely autonomously. A fiber optic cable is cut by a construction crew. The swarm of agents in the network detects the outage in microseconds and reroutes traffic, maybe by forming a high-bandwidth wireless mesh between rooftops to heal the breach before any user even notices a glitch. No human has to type a command.
That's the dream of every network operator. Where are we on that journey? Is it science fiction or is it around the corner?
It's a mix. At the top end, you have things like Edge AI for simple inference and basic federated learning. The report puts those at TRL 7 or 8, which means the system is proven and qualified. You can go out and buy commercial products that do this today. Then you have swarm intelligence for things like drone coordination or massive sensor networks. That's sitting at around TRL 5 or 6. It's been demonstrated in relevant environments. We have successful pilots, but it's not yet a mainstream off-the-shelf product. We're still working out the kinks.
And the full vision, the complete AI-native zero-touch 6G network.
That's still down at TRL 3 or 4. It's a proof of concept. We've shown the basic principles work in a lab, but the complex architecture to make it all work together at a global scale is still very much in the research and development phase.
So given those levels, what does the practical roadmap look like for the rest of this decade?
The report lays out a pretty plausible three-phase roadmap. Right now, through 2026 and 2027, we're in the foundational phase. This is all about getting the building blocks in place, widespread pilots of Edge AI, getting those A2A protocols standardized so vendor equipment can talk to each other.
Phase 2.
That's the intermediate phase. From roughly 2028 to 2030, you'll see hybrid networks where some functions are autonomous and others are still centrally controlled. And you'll start to see swarm intelligence moving into production for specific, non-mission critical applications like managing smart agriculture sensors.
And then the final phase.
2030 and beyond. That's the advanced phase, aligned with the main rollout of 6G. That's when we start to see the first truly autonomous networks where the native AI vision really starts to become a reality. If you're an operator or an enterprise building a network today, what should you do?
The first recommendation is clear. Go hybrid. Don't try to jump to a fully decentralized anarchic swarm tomorrow. You use that edge fog cloud hierarchy. You get the benefits of local speed and responsiveness at the edge, but with the safety net and strategic oversight of a centralized cloud component.
And privacy first.
The report argues that federated learning isn't just a nice-to-have feature, it's becoming the key to regulatory compliance. If you want to use sensitive customer or operational data to build smart systems, you have to embrace techniques that keep that data local.
They also really emphasize the importance of standardization.
You cannot build a global, interoperable swarm if the bees all speak different languages. Those A2A and MCP protocols we talked about are non-negotiable for this to scale beyond single vendor experiments. So if I'm an engineer listening to this right now, what's my big takeaway?
You definitely need to broaden your scope. If you're a radio frequency engineer, you can't just think about waveforms anymore. You need to start understanding loss functions and gradients and model optimization. And if you're a data scientist, you need to understand the real-world constraints of latency, jitter, and fading channels in a wireless network.
The silos are collapsing.
The silos have to collapse. The network and the AI have to be co-designed from the ground up.
And what about for the business leaders? How does this change the game for them?
The entire business model for a telecom operator is going to change. We are moving from selling connectivity to selling intelligence. It's a move toward AIs as a service delivered from the edge. The carrier isn't just selling you a data plan anymore. They're selling you the secure, low latency compute and AI capabilities to run your autonomous factory or your smart city.
This is such a huge shift in thinking. We're moving from manually operating the network to parenting it, guiding it.
This has been an incredible journey. We've gone from the fundamental physics of the cloud bottleneck to these autonomous agents negotiating for spectrum like traders on a stock exchange, all the way to the telepathic evolving swarms of the future.
Okay, let's try and pull this all together. If there's one single big idea, what is it?
I think the big idea is the shift in perspective. For 50 years, we've thought about connecting devices. The big takeaway from this report is that we are moving from building a network of connected devices to building an architecture of autonomy. It's not about just having a smarter phone in your pocket. It's about living and working inside a smarter environment where the network fabric itself is an intelligent, adaptive computer that organizes itself to serve your needs.
The environment becomes the computer. That's a really powerful way to think about it.
It's a complete paradigm shift.
We are witnessing a fundamental transition. We are moving away from a static, centralized network to a living, breathing, self-organizing digital ecosystem. It's about building a digital infrastructure that can actually handle the complexity of the world we're building. It's about resilience, it's about privacy, and it's about enabling those truly futuristic applications like autonomous citywide traffic flow or reliable remote surgery that simply cannot exist on today's fragile, centralized architecture. Distributed artificial intelligence is central to the evolution of 5G Advanced and 6G, redefining how wireless networks are designed, operated, and trusted in the autonomous era.
It really is the future of the field.
And if you are interested in gaining a deeper understanding of the transformative power of wireless technology, the Alpert Research Team runs webinars where they explore these cutting-edge wireless innovations, their applications, and their implications. We encourage you to click the links below to learn more.
It's well worth your time if this topic is interesting to you.
Thanks for listening. We'll see you next time.